Hi, my name is Veronica and I'm a graduate student in chemistry at Cornell University.
My name is Renee. I'm also a graduate student in chemistry. And basically what we're going to do today is kind of walk you through a demo that a member of our group developed about salt bridges and electrochemistry.
So I'm going to go through the materials that are provided in the kit for each group. So each group is going to need about 6 dram vials. They come in a little holder. We will need an eyedropper, a multimeter with some alligator clips, and some copper wire. So that's what each group is going to get. For the class in general, we will provide you with sodium chloride and copper sulfate. These will come pre-measured as solids in these containers, and the teachers only have to add water to this. You will need to provide 2 beakers to just hold the solutions. Furthermore, we'll provide you with some aluminum foil, sponges, rubber bands, and some LED lights to light up once we have a complete battery.
So you will also get a folder that comes with the package. And if you open up the folder, what you'll see first is a checklist of every material that should be in the box when you receive it. The next thing is a little background reading that you can hand out to your students either before they do the activity or after they do the activity, just to give them a better feeling for what is going on with oxidation and reduction reactions, etc. Then for the teachers, there's a modules sheet here where you basically, it tells you about the next generation science standards that you need and that will be fulfilled by doing this activity. And then you get the 3 activity sheets for each activity, and the students can go ahead and look through these and fill these out. So you have the first one, which is exploring half reactions, followed by building a battery, and then followed by exploring salt bridges. So then you can have the students basically work their way through all of these activities. And then finally what you have is just a safety data sheet for the chemicals that you'll be using, in particular copper sulfate. So yeah, so you have all these materials in the folder as well. Okay, so the first activity is just for the students to get a feeling for half reactions by taking some aluminum and a solution of copper sulfate and trying to observe the reactivity between the copper sulfate and the aluminum foil. So you have a small piece of aluminum foil, and I think it's a good idea to have your students fold the aluminum in half, or in fourths if you want. And so when you have your aluminum, you take your solution of copper sulfate, and the first things the student should do is drop a little bit of your copper sulfate solution onto your aluminum foil, and what you should notice is that there is nothing that's really going on. And this is because you need some sort of catalyst to activate the reaction. And so the catalyst that we're using is a solution of sodium chloride. And so once you add the sodium chloride to the aluminum foil with your copper sulfate, you can have your students mix it up a little bit, and then you'll start to see a reaction occur if you look closely at the aluminum. And so what's going on here is that the copper sulfate is actually going through a redox half reaction, and then the aluminum is actually going through the other half reaction, where the aluminum is now giving up electrons and getting oxidized, and the copper is now grabbing those electrons and getting reduced to form copper solid. And so if you have the students work through this sheet here, what you can see, you can have them basically write down their observations before they add the sodium chloride and after they add the sodium chloride. And then it gives them kind of an idea of what's going on by looking at the aluminum, which once you add the sodium chloride, you get the aluminum to lose electrons and then the copper to gain electrons and get reduced. And then you can go into explaining how this electron transfer is basically a downhill reaction by having the aluminum give up electrons to the copper. And then you can have the students sort of fill out this, like where the electrons are going in the salt bridge.
So after measuring the current, your students are going to have to measure the voltage as well. So for that, you'll have to change the setting from 20 M to 20 at DCV. And the concept is going to be the same. You'll connect the alligator clips to the aluminum foil and the copper wire. And the voltmeter should show a reading, which it does. So your students are going to note down the numbers that they record in this table and go through every single salt bridge that we have provided. The sponge, the dry paper towel, the wet paper towel, the rubber band, and lastly, no salt bridge at all. Alright, so now we're going to move on to the third activity, which is to build a battery. In the second activity, you went through all the different salt bridges and hopefully figured out that a wet sponge is the best salt bridge. So now you're going to take essentially 3 little batteries and put them into series. And for that, you take the block and 6 little vials and fill them alternatingly with copper sulfate solution and sodium chloride solution. So here, for instance, we have in the first row the first battery. Here is sodium chloride solution with a sponge and aluminum foil. Right next to some copper sulfate solution with a little bit of copper wire. Then we alternate it and have on the left side here some copper sulfate solution, and here sodium chloride. This whole thing is also depicted actually in the worksheet, where A is the anode with sodium chloride solution and C with the blue lines is the cathode with copper sulfate solution. This little yellow rectangle is symbolizing the sponge, so the salt bridge. And in order to put them now into series, you have to take 2 adjacent batteries and just wrap the aluminum foil around some of the copper wire. So you're going to do that with 2 of the batteries. That's also depicted actually in the diagram with this black line here and here. So if you do that, and then take your and make sure that, of course, your salt bridges are connecting the anode and the cathode. And if you then take the voltmeter and try to measure the voltage or the current, you should see a reading, which we do. So right now we have a voltage of roughly 2.3 volts. And if we now, instead of taking the voltmeter, take a little LED and connect that to the first battery, or the cathode of the first battery and the anode of the last battery, we should ideally see the LED light up, which we do.
Yeah, and if you guys have a difficult time connecting, because these are really short, you can use the alligator clips to connect one end to the final end of your battery. And then one thing that you can do after you go through this worksheet, if you're in a more advanced science class and you're trying to teach your kids about series versus parallel, you can go into explaining why it works when the batteries are in series, because you get that increase in voltage. And then you can also have 2 groups come together and put 6 batteries to get a blue LED to light up, and try to see if they can get different colors to light up as well. We hope we found this video helpful, and we hope we were able to thoroughly explain how to use it. If you do want to use this activity and this demo, we have it online in our lending library, so feel free to request to borrow it. If you have any questions or run into any issues or concerns when you do use the kit, please don't hesitate to email us and we can try to help you. Thank you.
Thanks.